Hello everyone, welcome back to our second video in our AP Calc AB adventure. Today we're going to talk about estimating limits from graphs and tables. If you remember from last time, our first video dealt with understanding what a limit was and then how to write one out algebraically. So today we're going to focus a little bit more on figuring out what limits are when we're given a function in graphical form or tabular form. This video may end up being two parts depending on how long it takes us to get through it. Again, my intention is to keep these between about 15 and 20 minutes so that you have plenty of time to pause and rewind and write down your questions and notes without this taking multiple hours. So let's jump right in, and we will break this into two parts if we need to. Also, I guess one more thing. When you are going through this video, not only do you want to write down the notes, but a good idea would be to try problems on your own before you see my solutions for them. So if it looks like something that you could try to figure out, or maybe you have enough background knowledge to sort of piece together, I would encourage you to take a couple minutes, take a crack at it on your own, and then press the play button and compare your work to mine and see if you have any misconceptions, and if you do, try to figure out what they are. But that's certainly going to be more beneficial for you than just copying everything down without really thinking through it a whole lot. All right, let's get started. Let's look at number one. Does the function have a limit as x approaches 1? And if so, what is it? So let me get out my pen here. If you remember back to our first lesson, limit depends on what the function approaches, and we have to approach the point from both sides. So we approach from the positive side or the right-hand side, we approach from the negative side or the left-hand side, and we can clearly see that they both approach the same value, y equals 5. For simplicity's sake, I'm just going to call this function f of x. So the limit as x approaches 1 of f of x is equal to 5. Now you may notice that there is a discontinuity here, specifically a point discontinuity. But let's look at question 2 and think about whether that has any, whether that has an influence on what our limit is. So number 2 says, explain why your answer to number 1 does not depend on whether the function is defined at x equals 1. Well, again, it kind of goes back to our idea of what a limit is. A limit is what the function approaches. It is not what the function's value actually is. So our function could be defined, and maybe, the value at x equals 1 is y equals 1. Well, it doesn't matter if whatever that value is, because it's based on these red arrows. It's based on what the function is approaching, regardless of what the value of the function actually is at that point. So a limit, let's see if my pen works. Depends on what the function approaches from the positive and the negative side. Now, I bought this stylus, and turns out it's easier to write with my finger than it is this stylus. So I guess we'll keep going with that. Okay, let's move on to our next example. Now again, here's a problem where I would encourage you to pause the video and answer these parts A through D and even part 4, and then come back and take a listen. So we're going to function here f of x, and we have 4 limits to evaluate. And based on what we did in our previous lesson, you should be able to evaluate these on your own. First one, the limit of f of x as x approaches 3. Well, let's approach 3 from both sides. And we can see that the function is clearly approaching 2. Now if we look at the limit as x approaches -1, but from the positive side. So we strictly only approach from the positive side, we are approaching -2. Now if we, for part C, we need to approach from the negative side or the left-hand side, and we see the function is approaching -1. So right away, there should be some alarm bells going off in your head, and you're like, okay, these one-sided limits are different. And if the one-sided limits are different, that should tell us something about the actual limit, which is what part D is asking us about. So the actual limit, or the regular limit for f of x as x approaches -1, does not exist, because the one-sided limits are different. And that's the first key thing that we need to understand about limits, is that for them to exist, the one-sided limits must be equal to one another. So it says, explain in your own words when a limit will not exist. Well, when the one-sided limits are not equal. And this is not going to be the only time when limits do not exist, but based on this example, that's what we should be taking away. So let's move on to the next page. All right, again, another example for you. This one's a little different. It's a little trickier than ones we worked on before, because we have these infinity symbols going on. But again, take a crack at it on your own, and then come back and watch the rest of this video. So first one says the limit of g of x as x approaches -infinity. So here's the thing. Infinity is not a number. It's an idea. And if we're approaching -infinity, you can only approach it one way. You can only approach it moving to the left. So again, if you think about the x-axis, -infinity, again, it's not a number, so you can't place it on the number line. But the idea is that as you move farther and farther to the left, you're approaching -infinity. And if we look at this graph, it looks like there's an asymptote at y equals 0. So it looks like the function will never cross this axis. So the function's going to get closer and closer to 0 without ever touching it. So that would be the answer to that limit. If we go the other way, we're actually going to run into the same idea. So as we approach positive infinity, on the x-axis, we're going to be approaching 0 on the y-axis. Okay, so hopefully those first two, A and B, are fairly straightforward. Again, as you approach -infinity, you only have to approach it from one side. Same with positive infinity. Let's go down to part C. So as x approaches -1, we need to figure out the limit of g of x. Now, because this is not a one-sided limit, we do need to approach from both sides. So I'm going to get rid of all this other stuff. So -1, let's approach from the left-hand side. And let's approach from the right-hand side. Now, right away, without even having to give answers for what this function is approaching from both the left and the right-hand side, we can clearly see that it's not approaching the same number. So we can right away put D and D. We'll go back and fill out our answers for parts A and B here. Now, we are being asked for part D, find the limit as x approaches +1. Choose a different color here. I'll use green. So +1 from the left, +1 from the right. Again, they are clearly approaching different numbers, so we are going to say D and D. here's where it gets a little tricky. We're going to put a new idea forward here for part E. So the limit as x approaches 1, but strictly from the positive side. So let me erase all this other stuff. So the green arrow now is the function approaching 1 from the positive side. And again, just looks like it's going straight up, right? We can see that there's an asymptote at 1, and the function is just continually going up. So there's actually two ways you may see answers, or two answers you may see to this problem. The first one would be DND, right? Because the function is not approaching a real number, right? It's constantly going up and up and up and up and up. So it's not, there's no asymptote there to stop it. It's going to continually, excuse me, it's going to continually increase. Now, you may see infinity as an answer here, right? Because if our function is constantly increasing, well, it's going to approach that idea of infinity, right? But again, infinity is not a real number, and the answers to limits are going to be real numbers. However, there is this idea of infinite limits. Okay, and if we're talking about infinite limits, then we're allowed to use the symbol infinity, either positive or negative infinity, as answers. Good news is they will never trick you on an AP Calc exam and have both DND and infinity as answers, right? If they're asking for the solution to a specific limit, they'll have one or the other. And you need to know that they could both represent the same thing, right? Technically, the limit does not exist because it does not approach a real number. But if we want to use the idea of infinite limits, then we could put infinity here. So again, this is only correct if we are talking about infinite limits. So for number 6, a limit will not exist when the function is approaching positive or negative infinity. So a limit does not exist when function approaches positive or negative infinity. Again, and that's just because if we go down to the core definition of a limit, it's when the function approaches a real number. So if it approaches positive infinity, that's not a real number, it's an idea, so technically the limit does not exist. Again, however, when we do talk about infinite limits, you will be able to write positive or negative infinity. Okay, both would be acceptable in this case, DND or positive infinity for part E. And again, the reason we incorporate infinite limits is because it's more specific, right, than just saying DND, because a function can have a limit that does not exist, but that may not mean the function's always going to infinity. And just because I think this is important, let's go down and take a look here. I'm going to give you an example of what I'm talking about. Just give you a quick function here. Okay, so we're going to look at two limits of this function. We'll say the limit as x approach. I can't get too close to the edge of the screen. Limit as x approaches -5, and the limit as x approaches 4. Sorry, we should certainly have our function here as well. We'll just call this f of x. Notation is important. Okay, so if we're looking at the limit as x approaches -5, well, if we trace this, right, from the left-hand side and trace it from the right-hand side, we can clearly see that this limit does not exist because the function's approaching different values from both the positive and the negative side. Now, if we come over here to x equals 4, and actually let me continue this function. Right, as we trace the function from both the left and the right-hand side, yes, the limit does not exist because it is not approaching a real number, but we could give the reader a better idea of what the function is doing by saying it approaches -infinity under the idea of infinite limits. Right, so you could say DND, but then the reader doesn't know if there's a jump discontinuity. They don't know if the function's approaching positive or negative infinity, etc. But if we say that this limit is equal to -infinity under the idea of infinite limits, okay, then the reader has a better understanding of, what's going on at the function at x equals 4. So again, that's why we bring in this idea of infinite limits. Again, technically, the limit does not exist, but it allows us to be more precise with our answer by incorporating infinite limits. Okay, I'm going to go back up and see where we're at, and we may have to stop the video here, but we'll see if we have time for another example. Yep, so we're going to stop the video here. In our next video, we will start moving into evaluating limits by looking at a table, because that is a new concept. I don't want to try to rush through that in a couple minutes. All right, this is Mr. Fawcett. Enjoy the rest of your day.